Okay, so Jean just let me know there that I was live, but also not live at the same time. Um, I don't know if I'll be able to recover from what was going on before, but I'll just carry on from where I was going. So basically I was just tackling these first two. We're on Dicey Battle. I was tackling these first two bonuses, which are just about the number of dice across all the levels. And I built this thing which takes the kind of takes the 1 to 100, the question numbers, takes the kind of columns next to that, and then filters just to the dice. And we answered the first question with a big count A here, which was to count the number of dice thrown. Next up, we're going to throw the dice in a long sequence. You start with 0 points, add the current number of pips, but if it's a 6, instead you multiply it. And the question is, which game number will bring your score above 1 million points? So I think what I want to do here is have a kind of here's my carried forward score. Here's my, so obviously these are all different lengths. So I could build a lambda that kind of goes through these one by one with scan, I think. Let's try that because it scares me. So so let's start with 0 equals scan. And we're going to start with this number, and we're going to scan through this. And the function we're going to do is you have to start with AV for a scan. So A is the accumulator, the one that kind of moves through the whole thing. And the value is going to be like each of these 4 things in turn. So we're going to go if V equals 6, A times 6, and otherwise A plus V. So what does that do? +4, that checks out, I think. And then if we just replace that with reduce, it'll take only the final value, I think. Actually, I don't need 2 columns here, do I? Just do this. So this is game number 1. And I'm just going to basically drag that down. The question is, when do you first go over 1 million? And it looks like that's here. It's game 31. Oh, excellent. Okay. And then for this one, I clearly need to do level 3. Excellent. Thank you. Thanks, Jean. I'm glad I didn't lose too much thanks to your timely advice there. We'll see if we can recover what's gone. But yeah, that's very helpful. Thank you. Cool. So we've done those 2 bonuses. I mean, I'm definitely going to need a worker sheet for this one. So let's get it. You see here that the number of dice is changing between the different levels, which makes it a bit tricky. Let's see if we can do maybe just these first 2 here. So dice roll +2. So I think we just want the 2 biggest dice rolls and then add 2. So yeah, we can do this one here. So if we do large of this, oh no, hang on. Let's dice denomit, which I don't have. Let's do uni code, this -9855. And just copy that down. Here and after, we only throw 1 dice. So I'm just going to go equals large of that, and then sequence of 2. And I'm just going to sum that and add 2. And because 1 is greater than blank, we can't take the largest 2 here because there's only 1. There we go. So not doing kind of a data table approach here helped me spot the issue with these ones. But obviously the data table approach gives you a lot more room to kind of build and work with. So in level 2, again, the number of dice is changing. So I'm going to try to do it just here like this. I'll probably just do these ones by hand and fill in answers for the rest of them. So battle axe, deal damage equal to twice the dice roll, can only take numbers 1 to 4. Broadsword, deal damage equal to the dice roll plus 2. So if we've got a 4 or a 3, then we definitely want to use the, well, priority is the 4, but we definitely want to use the battle axe on one of those. The broadsword, deal damage equal to dice roll plus 2. So broadsword is just the biggest that we have otherwise. So I think we want basically the largest number under 4, and then the largest kind of number that's not already taken. So let's do our dice to num, or Harry, stop saying dice to num if you've not got it. Let's go there, and then copy all this down. Just get rid of these. So what's our biggest number less than 4? Equals if this is less than or equal to 4. This, otherwise 0. If nothing is greater than 4, then 0, right? Yeah, so we want max of that. You see that? You see, there's so many different complicated cases going on here. So you might not have anything under 4. You might have 2 4s, like here, in which case we only want to filter out kind of one of them. Let's carry on like this and see if we can get it to go. So basically, I'm going to roll a 4 here. So I'm going to feed this a 4, and when I drag this down, then I can see whether there's any value errors or something maybe that's coming out of here, or I can kind of spot zeros. If I just do NA, does that work? Yes. So this will hopefully say NA if there's nothing greater than 4 like there is here. To be honest, it would probably be quicker just to do this by hand. But let's carry on with the formula approach. And so biggest, excluding that. So I think we want to do no doubles equals, so assuming there are no doubles, it's filter this where this is not equal to that. And then it's just going to be max of that. So kind of in the default case where we have a kind of good spread, that's what the answer is going to be. Oops, someone's sent me a message. Don't worry about that later. So it's interesting. Why is this returning NA when the other one wasn't? Oh, because there's nothing. Okay, fine. You can't use NA. That's okay. And then I'll just flag whether there are any doubles here. So equals count if that is greater than or equal to 2. Okay, so you see he's thrown in a few doubles here, which no less than I expect. But we'll adjust these ones manually. And we'll also adjust this one manually and this one because they're both zeros. So I think I'm just going to add up, basically just going to add up these two numbers here. And as I say, kind of this would obviously be much easier to do by hand, but I think this will put me in good thinking mind and practice for the later levels, which will involve this kind of thing, but a lot more of it. So where this is true, I'm just going to do it by hand. So instead of biggest excluding that being 4, so I basically want to add 3 to this, I think. Oh no, actually, before I sum this, I need to multiply this one by 2. because we double the points that go into it. So if this, then NA, and otherwise this. So these are going to be my answers, and I'll fill in these NA ones. So I think this is going to be 12 because we'll double one 4 and add on the other. This one has no 4, so it's going to be 6 plus 3. It's going to be 9, I think. 3, 5, so we can't use the thing that doubles it. So this is just going to be 5. And then same there. Oh, but we do have to add 2 as well, actually. So let's add 2 to all of these. And I'm just going to look at these 2 as well, because I think we only get to use one piece of equipment for these, actually for all 4 of these. So let's just do these manually. So the question is basically, is it going to be better to double it or to add 2? And I think it's going to be better to double this one. It's going to be better to, it's the same actually for this one. It's going to be better to add 2 for this one. And it's going to be, yeah, just add 2 for this one as well. And there we go, we got it. Real life, I would have done that by hand in the actual competition. Right, so let's move that out of the way. And let's get a second window up in order to build our kind of general solution. Michael looking very dapper there. Nice smile. Cool. So, I mean, I could probably steal this and then stick in example 3. Now, I'm not sure the example is going to cover every scenario on this case. So I don't know how helpful the examples are going to be, but I'm sure we'll find out. And I'm just going to kind of, I'll probably just do it like this. So I'll have the same kind of format as the beginning, where instead of one big dynamic array, everything is split out into 3. Okay, 3 turns. So we have a new type of equipment with a countdown. The rifle needs gunpowder. In our game, we use dice pips as gunpowder. I don't know about the logistics of that, but let's roll with it. Required amount of pips for the rifle to shoot is 8. You can put as many dice into the rifle every turn as you find optimal. Once you reach 8, the rifle shoots and deals 12 points of damage to the opponent. It can be reloaded in the next turn and deal damage again. Okay. And the dice and pips persist between turns. Okay. You may overload the rifle with no effect. So at the end of the turn, if it's above 12, we fire it, and if not, we don't. And it kind of carries over if we, so maybe we can, in some scenarios, put a kind of bigger dice roll into the rifle over the sword, and it'll help us hit that 12 on turn 3 or something. So this is very complicated, and we probably need to try all of the combinations. Great. Okay, how are we going to tackle this? So across the 3 turns, I'm trying to decide. So either you're going to put 3 things or 4 things into the rifle every time, I think, because there's no advantage to not putting something in the rifle, I believe. So what are our options going to be? It's going to be kind of 3, 4. You might put 3 things in, then 4 things, and 3 things. You might put in 4 things, then 4 things, and 3 things. So I think there's kind of 8 different options of that form, because there's you either 3 or 4, then you're 3 or 4, then you're 3 or 4. So in terms of number of things going into the rifle, we've got 8 options, and then each of those, there's kind of a choice in one case for which one you put in the sword. So you're going to have the 8 from into rifle, and you're going to have 4 from into sword, but it's kind of in half of those 8 cases. Before I build anything out, I will just read the medium very hard. Okay. Read the next one, see if the rifle's still around. So there's no rifle in level 4. There's no rifle in level 5, but there is a dice cannon, which reusable as many times as you like, which has kind of got similar mechanics. Okay. So I think my solution, whatever it is not going to scale nicely to the other levels. Let's build out our 32 different options. So I'm trying to work out whether I can kind of calculate the formulas pretty easily in like one cell, and that way I could lay out my 32 in multiple columns. I think so. So I'll set up the sequence across, which is going to be the which of the four is sword, and then this is going to be rifle rounds, and we're basically going to do binary sequence of 8. So deck to bin, I think it's called. And then if I do sequence of 8, see if that works. Yes. So subtract 1 from that. No. Subtract 1 from that. So here, so I think implicitly we're considering zeros for the rest of these. So I'm just going to kind of pad this left with zeros. I don't think there's a pad function in Excel, no. Well, it's only 8. I'll just do it manually. So 0, 0, 0, 0, 0, 1, 0, 1, 0, and then 0, 1, 1. And then these are just the same. Cool. So here are my kind of 3, or 4. So let's say that 1 equals 3 in rifle, and 1 equals 3 in rifle, 0 equals 4 in rifle. Quick sip from that. Cool. So 0 is 4 in rifle. So let's kind of go through the sequence. We're going to use mid of this. Starting number is going to be sequence of 3, and we're going to grab 1 each time. Mid of this sequence of 3, and grab 1 each time. Then if this is 0, if that is equal to 0, so I think we want to know which turn we're on as well. So let's do, let sequence 3 be sequence of 3 be turn number. If mid of that turn number is 1, 0, otherwise okay, so the let actually gets declared the other way around. Okay. So we're picking up whether, whether we're in a round where we use all 4 or 3. So if it is 0, then what do we want to do? We want to get whatever turn we're on, and we want to kind of get the corresponding one of these. So I'm going to let dice. Actually, we should just convert these into pips as well, shouldn't we? So it's Unicode that -9855. And that kind of gives us the value of the dice. Cool. So what we want to do is we want to say dice is equal to index of I think this works if I do that. No. So there's some way with index to use the fourth argument here to select across the 3 different. Let's just look it up. In Excel index fourth argument. Fourth argument. Okay, so maybe I have to put it in brackets. It would kind of make sense. So if I do, oops, no. Okay, dice is going to be equal to index, open bracket, this. I should lock all of that. 1, 2, 3, 4, 5, 6. And then the row number is going to be 1. The column number is going to be turn number. No, it's not. It's going to be this number here. And the area number is going to be turn number. So if I just return dice, what does this say? A 1, 4, 1. 1, 4, 1. What if this is a sequence of 4 instead? Hmm. So I think my amazing idea for areas is returning like the first one of area 1 and of area 2 and so on. And what I needed to do was actually take kind of only the current turn number. Let's just go back to this. So you see it's taking 1, 4, and 1 here. Whereas what I want, no, I think actually this is fine, isn't it? Hmm. So basically I want this to be sequence of 4. Yeah, let's just stick with this being sequence of 4, and I'll forget about these other ones for now. So now we've got kind of the different dice across the columns. And then So if the turn number is 0, then we want basically the dice to go into the rifle, and I'm going to have to carry that over to other turns. So let's just say it's some of the dice for now, and some of index dice turn. No, yeah, turn number. So what does that say now? 666. Some index of dice of turn 1, 4, and 1. Okay, so I think what this is doing is it's now adding up the first of each one, but I don't want it to do that. Have I got the columns and the rows the right way around? So I would have thought this sum here would be summing up like the columns, but actually it's just summing the first row. So if the column number is the turn number, and the turn number in the first one should be 1, I would have thought. Maybe if we get rid of this sum and just replace it with a concat, we can see what's going into it. With the res. Yeah. Let's just try this. No, so you see, we're only getting the first one. I think this is a kind of dynamic array is collapsing it in a way that I wouldn't have expected. Okay, well that kind of ruins that strategy. Let's just build out a full solution for the 0, 0, 0 case, and then let's kind of try to copy that to the other cases. So 0, 0, 0, in all 3 rounds, all 4 of them are going to be in the sword, so all 4 of these should give the same answer. So let's have this be turn 1, this be let's have this be turn 1, and then we'll have to build out a model of kind of multiples of these across. So this is turn 1. So where are we? We're on kind of mid. This 1, 1, and then if this is equal to 0, a text 0, of course, then I want to sum this up. And actually, what I should have done earlier with the index is I should have used a choose function instead. So I can choose based on the turn number. This is turn number 1, kind of whether I want to have these values, or these values. So that will be nice and kind of, only pick out the one I want. And I will have to lock all of these. Okay, so if we're on turn 0, we get these, and then basically want to add that up. So what is this? This is going to be the sum going into rifle. This is turn 1. And actually anything that starts with 0 has the same turn 1, because the first 0 is turn 1. So this is the sum going into the rifle. And then this is the sum going into the rifle if we kind of don't do that. So there's going to be 4 different versions of this. Let's forget about these for now, actually. Let's just do if 4, if 3, right? So if 4 go into rifle, if 3 go into rifle, and then there's going to be 4 of these. So kind of, except sequence of 4. So this is going to be equals sum of this, where sequence of it is not equal to that. Sum of that. So why is that returning 15? I would have thought this would return 14. Oh yeah, I didn't do a where. Okay, so if sequence of that equal to that, then this, and otherwise 0. Cool. So this is kind of the different options for round 1. And that leaves you in kind of some sort of state, and the state is made up of your points that you've already got, or the kind of damage you've already dealt. So let's be consistent with the case, call it damage, and kind of rifle carried forward. So we should get the sum going into the other weapon as well recorded. So sum going into sword. Right, so if it's 4, it's always going to be 0, and otherwise it's going to be equals index of this, that, not that, that. Except, oh no, the sword deals damage equal to the dice roll, so this is accurate. We're 30 minutes in. We're probably a bit over 30 minutes in because I did a bit of streaming before this, and we're still on level 3, which tells you a lot about how challenging this case is. What was the rule about the amount of damage we dealt? So if the rifle has 8 pips, we deal 12 damage, otherwise we deal damage equal to the dice roll. So what do we want to keep here? We want to keep anything with the highest carried over dice roll. Sorry, with the highest carried over rifle CF, or the highest damage, or like some combination of them both. So basically, if a case is strictly less in both the rifle CF and the damage, then we can eliminate it. So what is the damage here? It is sum this with this. I don't think you can fire the rifle twice if you hit 16. I'm not sure. But basically, if this is greater than 8, then we want 12 points of damage, and otherwise we want none. And then the rifle carried forward is going to be equal to what's it going to be equal to? Rifle carried forward is equal to, if this is greater than or equal to 8, 0, and otherwise it's this. So actually, the rifle doesn't have any carried forward here. So in this specific case, this kind of one where you're using the sword with the 6, the others are enough to shoot the rifle, and this is kind of the optimal case for certain. So kind of what in most cases you'd be able to do is you'd be able to copy this model twice more now and hook it up to level 2 and level 3. But because the second turn, if this rifle carried forward is not 0, well, based on all these different rifle carried forward values, we would need to try all of the combinations kind of differently. So actually, we would want 5 copies of the next level, 1 for each of these, and then 25 copies of the level after that. We can use dynamic arrays to cut that down a bit if we do this kind of approach, but I would be very worried that I'd miss something with that. So Yeah, I think we're gonna have to bite the bullet, unfortunately. So before I copy all of this, let's just make it as dynamic as we can. So I'm just put a nice heavy turn number here, and then I will um, basically use this choose function to choose the areas and hook it up to that kind of B20 value there. So anything that's kind of pointing at this range, we can just copy that formula over it. See the Copilot icon here? I think is that everything? Okay, so this is our kind of one dice model. And I'm sure what some would do. Does this go anywhere? Yes. Oh, yes. What some would do is they would convert this into a single big formula. Of course, you've got different treatment for is4 and is3, and you've got to kind of do some stacking here to get that to work. I mean, that would be the way to solve this neatly. But I think if I try that now, I'm just going to mess up something in the lambda. So let's just do the long form instead. So we're going to have turn 2, CF1. So this is going to be last turn. I did have 4 in the rifle. This turn, I'm going to have some other combination of the 5 things. So what have we got? We've got this whole model here. Turn 2, if4, if oh right, I linked this up to here. So basically, if it's 4, then that means we're putting all of them in. So let's get rid of this. Get rid of the if. We don't need it. There we go. Except we're not choosing 1 anymore. We're choosing 2 because it's turn 2. Once we have one turn 2 model, it'll be very easy to make the other ones. So let's just kind of make very clear what everything is. So this is turn 1. This is turn 2, A, and we're going to have A to E. So that's pointing there. This needs to point there as well. Copy that down. This also needs to point there. That's not the right cell. 31. So we've got 4214. These are the different pip values if we ignore things. That adds up, yep. And the damage is going to be the same thing. And you see here, this is a bit more complicated because the 7 being carried forward, even though you only do 4 damage, maybe in a later turn it lets you get to that kind of max shooting number. So this might actually be a better result than this one. Cool. So this is turn 2A. And then I'll have turn 2. In turn 2A, the rifle carried forward is 0, but But basically what I'm going to do is just add on this number here, and then for B to E, I'll add on kind of the other numbers. Freeze that, freeze that, freeze that, and freeze that. So that's my turn 2. Turn 2 B, C, D, and E. Turn 2 B. So the main difference is that this, no, hang on, this needs to be H22 for all of these. And then this one is going to be H24 for all of them. Oops, H24 for all of them. This one's going to be H25 for all of them. H25. This one's going to be H26 for all of them. This one's going to be H27 for all of them. H27. Okay, 9. Yep. So those are my various versions of turn 2. And then for each of these, we're going to do 3 that you can do on turn 3 across, and that'll bring it up to 25 options, and those will be all 25 options. This is a bloody complicated case, isn't it? Hopefully, is level 4 going to be easier? Maybe we'll only do a heuristic solution for level 4, like it was suggesting, because it's a lot of combinations here. And I should explain that a bit more. So, I'm obviously doing a full solution here for level 3, where we're considering every combination. But if you just kind of put the sword as the highest value each time, or kind of the highest value that lets this be 8 if possible, and you don't bother modeling all of the carried forwards and whatever, then actually that'll get you kind of a decent chunk of these answers, and that would be much more doable within the 30-minute time limit than what I'm doing here. This is kind of not very reasonable for 30 minutes as an approach. But I've started doing the full solution for this, so let's continue. This is going to be my turn 3. Turn 3A. So the first thing we'll change is this should point at this should point at that. This should point at that. I'm just going to put borders around this so we know exactly when I copy it, what to copy. So 1426. That's right. This one needs moving over. And then this one is going to point here, as is this, and these 4. Actually, I should add on the damage of the kind of path that we're following. So let's do that. So freeze that, freeze that, and go down. Freeze that. I mean, I don't really know what I'm going to do if this doesn't work first time. I don't think I'm going to debug it. I think I'll just move on. This is already ridiculous. So G25. It's going to be that one. plus G25. And then it's going to have to be G26, G26 plus G26. It's going to be G27. And these are going to be G27. Cool. So there's my different damages, and I will have to make 25 sets of adjustments to all of this. So damage here is going to be that plus G34 down, fill the border as well. These should all be 34, I think. Okay. And then my answer is going to be the max of all of kind of this set of damage across all 25 of those answers, which I think I should probably at least turn it into one number. So we only have to kind of add up one number 25 times. And then, they're going to be in regular rows and columns. So we'll probably be able to exploit that, hopefully, to add them all up nicely. So max damage is going to be the max of these. And if I am kind of making sure everything is nice and regular, just make sure there's the same gap between all of these, which there isn't. So 4, 2 blank, 1 blank. Like that. So those are all nice and regular, and I should be able to kind of pull everything out in a formulaic way, hopefully. Okay, let's fill this stuff in then. So this is this one's basically 0, 0, 0. And then instead of any links to that rifle CF, I want this rifle CF instead. This rifle CF instead. So if I hadn't added an extra row here, I could put like a number here, and I just change the single number and all of the indexes and everything would move. I could probably still do that. Speed this up a little bit. Should I do that? Yes, let's do it. So I'm going to delete this if3 row, which is kind of the problem child. And then I'm going to say this is going to be equal to 1. This is going to be 2. And then what we can do is I can say plus index that. And I don't want to freeze this, but I do want it to point at the right place the whole time. and 32, because I want it to move like when I copy across and across to other kind of sets of this. So I can't copy this whole column down because actually these formulas are different to the other ones. Actually, I can lock this one, I think. Okay. Okay, so I think that's right. And then I want the same thing. This seems fine already. And then this one does need the index, so we're going to go index of that by that. And again, I'm just going to have to collect this on all of them. Make sure it's pointing in the right cell. As my max. Just check very quickly that we're under the 48 from the example. Yeah, we're still under the 48, so we've not found the best one yet. So is that everything? So if I copy that, copy this here, something's gone wrong. So actually no, so this one starts at 24 damage and you end up with these sets of damage. I would expect this one to be kind of 8 less everywhere. And it looks like it is, except for this one where this is carried forward, and that makes sense. So yeah, I think that's probably right. So let's copy this 3 more times. 3, 4, and then 5. Okay, and then we're going to copy this down. What's gone wrong with the viewing there? I'm going to check all these formulas are pointing at, and we're going to have to move this down. N42, that's correct. N42, N42, N42. And these need moving down as well. And then this formula is the same all the way down. Yep. Down N42, 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 N42. Okay. So now we can copy that across 5 times as well. I'm hoping one of these at some point turns out to be 48. Because if it doesn't, I'm going to be very disappointed. These no, that doesn't link to anything, so that's fine. See when I'm sending messages. All right, your camera is being weird. It's flashing green. This happened earlier, but it fixed itself somehow. Okay, I will. Basically, I'll try to check that the connection is right. Seems okay. I don't know what else I can do. It just stopped. Excellent. Thank you. Cool. So I'm just going to do one more sense check here. So I know the solve of this is very boring. I'm sorry. I just want to do one level fully just to show what a full solution of this would have to look like, at least kind of in terms of the inner workings of it. Cool. So I've got 3 more of those to go. So copy that down. This goes here and down. 52, 52, 52. This goes down. Oops. Wonder if I can drag that along a bit more and give a bit more. Some things take a while. Advent of code yeah. Some things certainly do. I know that Michael probably enjoyed setting this question a lot, partially because of this. Cool. So those all look good to me. Looks good. Damage. This needs to go down here. N52, N52, and N52. Max is 46. That's we're approaching our 48. Seems like it might be quite a high scoring set. 40, 48, 47, 40. So we might well have a winner here. Of course, the advantage of this is I was going to write a kind of max ifs kind of across these columns, if the column header is max, but because it takes so long to set up, I can just read them off as I go, and I can see that this one's the biggest so far. So now I'm just hoping that there's not a, what's it called? Harry. There's not a kind of bigger one that comes out later, which is going to ruin my solution. Cool. So that goes there, down, and then 62, 62, and 62. This one goes here. It's fine. This one goes here. And then 62 again across all of these. Copy that 4 times. Nice. And then 1 more to go. Drag that there. Drag that there. I think I'm just thinking about whether it'd be good to do a programming solution for this. I think so. I think I could do it much faster if I set up like a class structure and something that cycled through all the combos. I wouldn't have to copy this 25 times like you do in Excel. Right, what am I doing? So this one's correct. These ones aren't. So I need to go and 72, 72, 72, 72. Yep, seems right. Okay, let's copy that 5 times. 39, 47, 46, 39. So it looks like the optimal one is this one here, which was use everything except for this 6 value in the rifle in round 1. Use, I guess I'm on the 3rd one along. Use everything except the 2 in the rifle the next round. That checks out because then you're shooting the rifle with your 2 4s. You would need both of them to shoot the rifle, and then you're keeping your kind of best one after that. And then the 3rd winner is to use the sword on the 4 and shoot the rifle with the rest, which checks out because these add up to 7, not 8. So this kind of makes sense. So what's my answer going to be? It's going to be equals max ifs this, and the column header has to say max. What does this say? Value error, of course it does. Let's just go equals max of this instead. 46, 40, 48, 47, 40. And then my final answer is going to be max of those. Cool. So sequence of what level are we in? 30 to sequence. It's probably 30 to 50. So 20 rows starting at 31. Yes. Cool. So I just need a data table now. Alt AWT. Column input cell. It's going to be this. And these are going to be my level 3 answers. And they're all right. Look at that. So this is the level of complexity that's needed to solve level 3 kind of properly. Maybe you could get this into one formula with a load of like recursive type things or reduces or whatever. But it's not really reasonable to do a full solution of this within the 30 minutes. We're over an hour already, plus the 10 minutes from before. So yeah, there we go. So I'm just going to call this level 3. And let's just solve level 4 and 5 heuristically. So clone this, level 4. So example 4 is what we're interested in. Get rid of the data table from here as well. How many points have I got? 550. It's really not that many points. I'll throw level 3 all the way to the end because I kind of don't really want it. Don't want to look at it ever again. Level 4. Put that there. Get rid of this. Drag this back over. Okay, so deal damage equal to the dice roll, numbers 1 to 4, damage equal to the dice roll plus 2. Any unused dice left at the end of turn 1 are discarded. We assume that nothing happens between your 2 turns. My 2 turns? Do I not have 3 turns? I'm just going to read this again. Hint, it will always be optimal to use the hook shot in any given turn. So this is very similar to level 2. We're choosing which 3 dice to use. And there's nothing happening between turns. So actually this is a lot easier. If I basically just go through and I can basically do a single turn solution here and then just copy it 3 times, which you couldn't do in the other one. So basically, I'm just going to apply all 3 of these to here, and then I will say if the hook shot is applied to an even number, say no. So this level is actually really not that bad. He says as he's about to get stomped by it, probably, but hopefully not. So I don't know. Maybe the level 3 really threw everybody off, but I like at the moment I feel like this level's a lot easier. We'll see. So so basically, I just want every combination of this. So I will use a super secret magic trick here, which I don't think anyone's shown before. I'm just going to do rand array of 4 with a kind of sort. Sort by maybe. No? Oh, I guess because this needs to be transposed. So actually, I'm not going to sort by those. I'm going to sort by a sequence of 4. And what I'm going to do is concat that, take the first 3 before I concat it, drag it down a lot, like a lot, take unique of it, and sort it. And hopefully this will be every combination of numbers 1 to 3, including 4, which I think would be... Can you calculate combinations in Excel? No, that's 4. It's be 4 times... well, it's 4 factorial, isn't it? Which is 24. And then this is before you unique it. Unique. Maybe it's not before unique it. Oh no, it is 4 factorial because the elimination of the kind of one that you knock off, you can always think of that as being at the end, and there's only one option for it. So it does just match the 4 factorial. So this is fine. So here are all of my combinations of which ones I'm going to take across the 3 levels. And I didn't have to write any kind of complicated formulas to do that. I just had to use randomness to my advantage. And I will just convert these to values because I don't like text in Excel. There we go. So here are my kind of choices for what the weapons are going to be. So equals let choices be mid of that sequence of 3, 1. And then I'm going to do battle axe in is going to be index choices of 1. Broadsword in is going to be index choices of 2. And then hookshot in is going to be index choices of 3. And then let's just return like hookshot in, for example, 3. Yeah. Cool. So the answer is going to be if a BA in is less than 4, BN times 2, and otherwise 0, plus it's not less than 4, it's less than or equal to 4, plus broadsword in plus 2 plus basically the max of these other two functions. So max of, no, actually, let's just go if is odd of hookshot in then 0, and otherwise it's going to be the max of if hookshot in, if hookshot in is less than or equal to 4, hookshot in times 2, 0, and otherwise hookshot in plus 2. Okay, so it thinks that the answer is 4, which seems a bit low here. Does that not seem a bit low? Well, let's kind of name them individually. So BA cont. So for the contribution, it's going to be that. BR cont is going to be that. And then hookshot cont is going to be that. And then the result is going to be hookshot cont plus BA cont plus BR cont. Okay, and then I can just okay, so what more am I doing? Number 1 is in the battle axe, so that contributes 2. Number 2 is in the broadsword, so I'd expect that to contribute 8. And then the hookshot would not be used. So I think something's going wrong with the broadsword. Broadsword cont. It's 4. So why am I getting 4 for the broadsword contribution? Well, what is the broadsword in? And it should be 6. It's 2. Index choices of 2. So what is choices? 1, 2, 3. Oh, right. So choices isn't this, it's index this value of that. One, 6, 3, excellent. And now if I return, what's it, br cont, no, br cont plus bs, not bs, what do I call it, hs cont plus ba cont. That's 10, which is much more like it. I think that's right. Cool. So now all I need to do is lock this, unlock the columns on this, and copy this across to there and to there. And then add those up. And what's the question? It's the max again. So max of that, 46, which matches the example. Excellent. And then this one's going to be, it's going to be sequence 2051. Yep. And Alt AW data table. That. Paste those in. And it's not right. Why is it not right? Hmm. let's have a look at, well, let's just check what the answers are. So for level 4, we're looking for 57 on that 51. Looking for 57 here, so we're too low. Right, so 51. And then what's our best? And let's see if we can beat it. So our best is 241. Oh wait, no. Okay, so the reason it's wrong is because it's actually the max of the individual 3 added together. Because the 3 turns, any one of those 3 turns could come after. Oh, I still got 24. Where did that come from? Oh, okay. So this here is the actual answer. Example 4. So now I'm getting that it could be 54, which is too high. So let's see where we're going wrong. So this is 21, and then claim that 3, 4, and 2 is the right way to do it. So this is 6, plus 7 is 13, plus the broadsword again is 21. That seems right to me. Okay, so I think this is okay. Next is 20. There's 2 ways we can get 20, it says. So 1, 2, and okay, yeah, 1. So that's 8. Plus 4 is 10. And then we're using the other 4. And so what is our hook shot contribution here? So I would expect it to be 8, and it is 8. 8 plus 4 plus the other 4. Okay, that also seems right to me. And then finally 13, which you can get with 2, 3, and 1. So contribution 2 from this one, 5 from this one, and then the 8 from this one, 13. So that also seems right to me. But it adds up to 54. Is the question wrong on this one? Reusing. Oh, it will not always be optimal to use the hook shot in any given turn. What? How could it not be? Like, why would using it with the broadsword? Okay, maybe it. Okay, maybe you've not got very many even numbers, right, and you prefer these two. But we've covered that case. I think the question might be wrong here. I'm afraid. I don't know. Or unless I'm missing something really obvious, because I've just hand checked this quite thoroughly. I mean, I will just check this one more time. So 3 goes into the battle axe, that's 6. The 5 goes into the broadsword, so that brings us to 13. And then the hook shot reuses the broadsword to give another 8. So yeah, I'm going to say, I don't know, I'm going to say the case is wrong, unfortunately, on this one. And someone who knows better can hopefully correct me in the comments. I will just paste these answers in to see if any of them are right, though. The one at the end is right. Okay, great. Okay, level 5. Well, the good news is the hook shot is no longer used. So, whatever the issue was, hopefully it won't show up again here. Maybe you can't put like a 4 and then the other 4 in the hook shot. I don't think so, because like that would be explicitly made clear if it was the case. Okay, level 5. Just let me do one more think about this. No, I don't see a way out of it. Okay, right, level 5. Luckily, you have some new equipment which can deliver the shock status effect. So there is going to be turn dependence here. Great. Okay, let's do a heuristic solution to level 5. The only way you get further turns is if you shock your opponent. So I think what I want to do is build something that says, if can shock, do shock. If not, maximize damage. Oh yeah, and that's basically what this is pointing you to as well. So basically, if there's a 6, we do this. If there's not a 6, we use this. And then anything else gets thrown in here. Okay, so let's build a 1-turn model of this. So is there a 6? Equals that equals 6. Or let's just say first 6. So false and not that, and that equals 6. So that's my first 6 there. Has 6 equals all of that. Okay, so the hammer Will the battle axe always be the smallest number less than 4? No, because the buzzer might have to be used instead if the only even numbers are less than 1 to 4, and maybe you've only got a 4. So if there's not a 6, we want the least 1 to 4-ish even number. So can buzz. So first even has even. Let's copy this. And we want no. If has 6, 6, and otherwise whatever we use the hammer on. So let's just close this. Hammer damage. So it's either 6 or it's TBD. Let's call that false. So are shocked. Can shock. Or did you say shocked? Shock to use equals if this equals 6 and nothing, and otherwise if this equals 2 then 2, and otherwise if this equals 4, 4, otherwise anyway. Cool, so that's our 2 main priority items. And then the dice thing is always less useful than the battle axe and the hammer, so you'd only ever like throw the rest of the dice in there. The battle axe is probably the one I want to use next, so let's go with like remaining dice. It's going to be equals so let's do a first shock to use equals if that equals that, then true. No, wait. Yeah, this is it. So basically we want the first one that equals the shocked to use value. And I'll probably have to like move all of these manually. Cool. So there we go. So actually we want to point this at shock to use, not hammer to use. So in this case, we don't use a shock. And this is what I mean with the examples kind of not always illustrating all the use cases, right? Like this example doesn't check the path where we use a shock. So our remaining dice is going to be equals filter, elim dice. So we're going to eliminate some dice. It's going to be equals or this and this. So we're going to eliminate that dice. So the remaining dice is going to be filter the dice where this is not true. So here are my remaining dice. And I don't care about the buzzer anymore. I do care about everything else though. So next is going to be, I think the next one in my heuristic, I'm going to do a heuristic solution this time. So rather than try the, all the combinations with the dice cannon, I'm just going to say always use the other two, and the battle axe. Battle axe is going to be the biggest remaining number under 4, and then the hammer on the biggest number, then the dice cannon and everything else. So biggest remaining under 4, and it's going to be equal to that. Filter that less than or equal to 4. Otherwise it's going to be NA. It's going to be the max of that. So that's my next priority. It's going to be elim dice. It's going to be equals used here, so we're just going to say false equals or. It's going to be or. Just grab it from here. It's going to be and, isn't it? Yeah. And that, and not that, and that equals that. I will actually just lock these, and then I'll have to make the adjustment when I copy the model over. Cool. So that's my used here. So remaining is now going to be equals that, where is empty of that, then true. Otherwise that is empty, is blank, it's called, isn't it? So now we're going to filter this by this not being true. So what was this? This was the battle axe, and then the hammer, and it's going to be equals. If this is not equal to 6, it's going to be max of these, and otherwise it's going to be 0. And then the dice cannon is going to be equals if that is not equal to 0. Well, actually, it's just going to be count of this minus that's not equal to 0. So the total damage is going to be damage from the dice, the hammer first pass, the hammer second pass, the battle axe times 2, and then if that's an error, then it's going to be 0. And this hammer first pass as well. That's going to be my damage. It's going to be 14 on the first turn, I think. So this example 5 answer should be more than 14, and it is. So hammer was the 6. The battle axe does 6 as well, I think. Yep. And then the dice cannon does 2. Cool. Okay. Let's copy that over and see if it works. I'm not that confident, to be honest. Seems fine. Seems fine. Why is what? Oh right, okay. If all that equals 2. If all that equals 2. Oh no, hang on. If all that equals 2. If all that equals 4. Cool, okay. Right, so this is one of the ones I have to move over. This is the other one. There might be a third one, I can't remember. Okay. And then I also want does shock. And that's going to be equals, that equals 6. Or that is not equal to NA. And then my final answer is going to be equal to this plus if this this plus if this this. And actually on this last round, I think I always want to use NA because I don't care about shocking them anymore. That gives me 34. The answer is 43. Okay. All right, so let's see if we can beat 34. So hammer deal damage. So this is definitely, we're using the 6 here, that's for sure. And then this would also get used, that's another 6. And then you stick both of these in the dice cannon, that makes it 14, which I think is right. Next up is the turn 2. And on turn 2, We can't shock with the hammer, so we're going to have to shock with the buzzer. So we'll shock with a 2. That seems right. And then that leaves us using the battle axe here for 8, and the hammer on this other 4 for 12, and then +1. So using the 2 here, using the battle axe here, I'm getting a total of 8 from that. But where's our hammer? Our hammer second pass only getting the 1. So why is this returning true? Oh, right. So I think what we want to do is that. There we go, that's more like it. Nice, and that gives me 38, which is still not right. So we're happy with the 14 at the beginning. I think we're happy with this 13 here. So why? So I think we don't care about this buzzer anymore. We can't shock with a hammer anyway, but I think basically we want to double this one. Use the hammer and the 2 dice cannons, and that does give you 11. Okay. So actually this is 2 levels now that I'm not convinced by, so I'm probably missing something from the instructions. See if any of them are right. Oh, hang on. I'm using example 4. I should be using example 5. Example 5 gives me 43, which is right. Not minus 19,580. Well, we'll look at those in a minute. But let's paste those in. Oh, they changed the number of dice. My God. Okay. Let's take a look at 77. So we can shock with this one, so I agree with the 6. Don't need to use the shock. Battle axe will double the 2 to the 4. So that gives us 10. And then the other 2 are the 1 and the 5, and they're going to have to go in the dice cannon, yeah. Okay, so we got 6 plus the double 2 is 4, plus the 2 in the dice cannon is 12, yeah. But we get a value error here. Okay, so let's put if error NA here. Let's recalculate that, paste these in. Okay, so that does tidy up that one. 81. Still wrong though. So 81. No 6s, so we will have to use one of the 2s for the shock. So down to 4, 1, and 2. So we get the 8 from there. We get the 2 from the hammer. So I agree with this 11. Next up, you can shock with the 6 again. Oh, but we're eliminating the dice wrong. So it's actually the same problem, but up here this time. If I was still in financial modeling practice, I'm sure I would have spotted that straight away. We use a lot of masks at Operis. That gets that one. Number 83, what's the bet? It's just going to be the exact same thing again with a different set of dice. Okay, so we do want to use a 4 to shock them here. The remaining dice. Yeah, this is going to be the exact same thing. There we go. So we've got all the ones with 4 dice correct. That's cool. Now onto the ones with 3 dice. And it's like especially cruel to put a 3 dice question on here. What I might do is just kind of copy this whole tab. Do a kind of, just get rid of these. This whole column. Really not like that though. And what levels were they? 86 onwards. No. Okay. Let's take a look then. So you're indeed on 86. I do want to shock. And then you can only use the 5 for the hammer. Can't use it for the battle axe. So I would expect this to be a score of 6, and it's not. Okay, so I think when I do this filter, how many other filters? I just want to filter out 0 as well. And that's all the filters. Cool. So now I get 32. That's all right. Yes. And I remembered to work on a different sheet, so I can do this level 3 sheet. So the way I would do this is I would have the max kind of column-wise as well, and then you can look up where the max is across and down. It better be a unique solution. And then you can know kind of which one of these there is, and then based on these numbers, you can then pick out which dice was dropped or not across all the 3 levels. But I'm sick of this now, so so I'm going to move on to the next one. Thank you very much, Michael, for the Dicey Battle. Bit of confusion over level 4 here, but aside from that, definitely a challenging case, should we say. Yeah, cool. So that's Dicey Battle. I should have made a copy of that before I start working on it. Elections are coming. This one, I think, is a bit friendly. Well, most of them are a lot friendlier than Dicey Battle, of course. So let's just copy that. Andrew G. What day is it today? The 18th of Jan. Got some salad I've got to eat before the end of the day. So I can't forget to do that. Nice. So this is the only case so far, I think, that's used like cell interiors. So that's quite interesting. We will do a find and replace on them to kind of get rid of the, like replace them with something we can then, use in formulas down here on level 4, I think. Cool. So how many votes were given to the purples? I think this is count if. This is that. This case is about elections, and I believe these 5 colours here are effectively the different parties. In the UK, the purples is UKIP. So yeah, I don't know if I'd. I'm much happier with example 1 personally than the example, question 20, for example. Okay, what is the highest? So level 2 is going to have some kind of voting system, and we're going to need to work out the maximum possible score somebody can get in it. 100 voters living in the country. That means from now on, well, including level 1, maybe there are always going to be 100 columns here. Maybe. Okay, so if 3 voters vote in a row for the same, okay, so you get kind of the nth triangle number where n is your kind of run of voters. So I think if it's going to show me up here, but I think it's probably 50-50. Yes, excellent. I'm going to get rid of this annoying Copilot floating thing as well. Cool. So, how many points will the BW party receive? Let's open another worksheet and kind of work it out on there. So I will build my thingamabob. So where are we? We're example 2. I'm going to go index case exclamation mark G to 100 plus G. It's going to be DA. Let's just try DA. It's not going to be DA, but it's going to be somewhere around there. Match this to case exclamation mark BB. So how many columns is that? 99. Okay, it's going to be DB. Cool. So actually, let's just put this down the column. And then we'll just have equals that equals BW. And then we'll say equals if that. So basically, if not that, So if we're not BW, we never get any points. If our next one is BW, if that is BW, then we're not going to have any points. And otherwise, we're going to have, let's call it 1 for now, but we'll make this better in a minute. So in these cases, we're not going to have any points. In these ones, we are. And it's going to be equals, and I'll just stick a random vote at the top here for a different party. And the number is going to be equal to X match BW in basically up from where we are. And we're looking for actually we want anything except BW. Oh, hi. Hi, Bo. How's it going? And then what I'll do is I'll do that for the five parties. So I'll have all 4 codes here. There's merge cells, yeah. So here are going to be my 5 parties, and then I'll just match all of these except the BW one they're interested in. Just got to lock all of this. Lock, lock, and lock. Why can't I copy and value paste here? Oh, I think it's my clipboard is acting up again with the 2 view windows. Let's just copy Alt H V V. There we go. Cool. So copy all of this down. And then I don't want to X match from the bottom. I want to X match from the top. So I do want an exact match, but we want to search last to first. And then if it's error, it's going to be 0. So then it's going to be the min of that where it's not equal to 0. And this should basically give us the amount of the run. So BW, there were 2 BWs here, and our answer is 2. And then you get down a bit, 44 BWs in a row. That doesn't seem right. We want to do a kind of countdown here, sequence of 100. And then when we do match this stuff, it's going to be that number minus that, basically. So it's going to be equals that minus that, and then maybe +1 or something. Oops. But then we've lost our kind of if error is 0. So I'm just going to wrap this in the if error 0. And actually, I'm just going to stick this in here instead. I think that's right. I'll stick the +1 within this bracket too. There we go. So here it's saying there's 4 to go before we hit the YB. Here it's saying there's 2 to go before the B. Here it's 1 to go before the B. So these are my kind of base, these are my run counts. And then the kind of score that you get out of there is going to be equal to that times that +1 over 2. Because 1 plus 2 plus 3 plus 4 is 10. And you can think about that by, if you have a kind of run, let's say it's up to 100, 1, 2, 3, 4, 5, dot, 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 100. You can pair the 1 and the 100 at the ends together, the 2 and the 99, the 3 and the 98, and so on. And you'll have 50 pairs of 101. So it would be, this would, 50 pairs that add up to 101, right? So this would be the kind of number would be the 50 would be the J3 over 2, and the 101 would be the number +1. So this is the answer to the case, 17. Let's hope that's right. Yep. And then the questions here are 21 to 40. Let's do XAW data table. Column input cell is going to be this. And those answers are right. Excellent. I didn't start a timer for this case. I don't know how long I've been going, but I'll just start the timer from there. I decided we'd move on with a simple system from level 1, which is just direct counts, I think. Each party will get exactly 20 votes. If he is fully correct, he will, okay. So we're basically we're bucketing the 5 of 5 election places over these, and then we're subtracting $10,000 compared to like some sum. So I'm just going to copy this. This was level 2. This is going to be level 3. Example 3. Example 3. Get rid of all this. Don't need it. Get rid of this data table as well. Don't need that anymore. So equals unique of these, and transpose that. Copy, value, paste. And then we're just going to do countif out of that, lock that. So there are my 5 things. So our base value is going to be 1,000,000. For each difference, the party loses 10,000. So stick that in there. Let's go equals abs that minus that. And then that times 10,000. That minus sum of that. 64. Yep, that seems right. Nice and easy. Sequence. It's probably going to be 20 levels. 41. Alt A WT. Column input cell is going to be this. Nice. And that's correct. And then was there a bonus around this? What's the minimum payment? So what's the minimum of these? 26. Oh, and I see bonus 3 here is basically the count of everything that's equal to BW. I think when we do our replace, we'll be fine here, but we're going to have to be careful on this one. So that's fine. So done level 3. Level 4, I'm just going to, in this other worksheet here, I'm just going to paste this table so I can, or I'm just going to show this table so I can have it. and then do a find and replace on basically these individual formats. So I'm going to choose format from cell this, and I'm going to replace that with P. I'm going to find this format and replace it with BW. I think I might have replaced all of them across the worksheet there. That's okay though, that's still fine. Gonna choose format from cell, red one, and the red one's gonna be R. And I'm gonna choose format from cell for the black ones. The last one I can do is I can just select blanks, which is nice. So if I kind of just go from the bottom left there, all the way along, just select blanks, then what? I think I might have selected objects instead of blanks. Oops. Okay, so select blanks. Yep. And these are going to be the YBs. Get rid of this. And that hasn't actually replaced all of them. Maybe I didn't go down all the way to the bottom. Okay, I think that's everything then. And then how many votes for the winning party? I mean, since I've got level 3 here anyway, I can just drag that. Level 4. Sample 4. And then it's just going to be 61 here. And it's going to be max of these. There we go, that's level 4. And now we've got level 5. So we don't need to grab G to DB here, we just need to grab G. I'll just move that there. And basically what I want to do is take the valid kind of party names here. I will just move this over so we have more room to work with. So I want to basically, from the beginning, extract these kind of combinations. And what's a bit difficult here is the BW. The BW is kind of B, has a B in it as well, and so does the YB. So if you had kind of YBW, you won't have a YBW, but you could have a YBBW, and you need to be careful that these B's in the middle aren't this B here. So I think what I could do here is just copy that down and do a substitute of YB with 5, a substitute on that with BW being 4, and then kind of just copy that 3 more times with the other ones. So P can be equal to 3, B can be equal to 2, and R can be equal to 1. Cool. And then if I just go mid of that sequence of 100, it will be 1 character. If I go 101, I'll just check that. Oh no, there's more than 100. What is the length of this? Actually, let's just make it dynamic to different lengths. So let's just go equals len of that. We can see there are 1,000 voters. Wow. Okay, and then countif just put sequence of 5 here. Countif this is equal to that. Cool. So that's 234. That's right. And then this is going to be level 81. Let's paste those in. And that's all good. So we've done levels 1 to 5. That was a lot easier than Dicey Battle. Only 8 minutes from when I started the timer. So that's good. And then how many votes were given for the BW party? So basically, I just want to count if this is 4. Do a data table of that. And it says including examples, which is a bit unusual, but let's roll with it. Alt A W T. So these are the level 5s. I'll just stick everything on a new sheet. Ooh. This is the level 5 ones for bonus 3. And then I want to basically just do countif this BW plus, and same thing, 1, 2, 4 times. So that was level 1. This is level 2. This is going to be level 3. Then finally, this is going to be level 4. 1599. So equals that plus sum of this. It's going to be my final answer, 5681. 5681, and that's right. And we got 1250. Okay, so that was elections are coming. That was relatively easy compared to Dicey Battle, I'd say. That's my timer. It took 10 minutes from when I started streaming. I'd only done levels 1 and 2. I can't remember if I did the bonuses, but I only did 1 and 2 since then, so it's not bad. So that gives us 500 by Tim Heng. And the date is still the 18th of Jan 2025. I don't know if I've done this one before. I don't think I have. Let's start the timer. Okay, so the card game 500 has 4 players and a modified, of course it does, a modified 43 card deck. Oh no. Okay, Trump suits and everything. This is very similar to Euchre so far. I don't know how to say that word, but let's say it's Euchre. Followed by the jack of the other same color suit as the Trump. Oh no. Is this not just Euchre again? Oh no, there's bidding this time. Oh no. This seems really hard already. We don't have a nice list of all the cards like we did for Euchre. This does not add up to 43, so these aren't all the cards. So the other ones we're taking out probably the 2, 3, 4, and 5. What would be the 43rd card though? Like I'd expect it to divide by 4. So I guess, do we have 3 jokers? Do I have 3 jokers? 1 joker? Seems really complicated. Let's just try level 1 to start with. Let's just get stuck in on level 1. How many spades does player 4 have? So it's going to be called level 1. We're going to have example 1 as the example. We're going to index case G to AW. We're going to match that to column B. Let's lock that. Name error. All right, because I've got the sheet name here. Oop. Oh no, it's gone non-responsive. Okay, there we go. So it looks a bit funny, doesn't it? Okay, fine. Strike through, strucken through diamond, basically. And that is all 43 cards. Okay, so what I will do is I will just grab all those, make a new tab called cards. And then we can kind of break out the card, suit, and then anything else that we want, we can kind of stick here. How many levels does this have? 5, okay. So the cards are dealt in the following order, 3 at a time, moving clockwise. Okay, I don't know why you would deal cards in such an overcomplicated manner, but let's roll with it. So I think what we want to do is kind of maintain the whole sequence of cards in the deck as we move through this. So let's have remaining cards, and let's have, let's just text join all of these. And then what we can do is we can say equals take 3. Why is this not doing what I expect? All right, there we go. So we can take 3 from there, and then that's going to leave this. Well, actually, let's just do equals drop count A of this. So we could do it like that if we kind of do this, right? Okay, so 6 of hearts. Get them referrer. Right, because what I want to do is I want to actually use that one instead. Okay, so the first 4 are these. Alt KU. Oh no, it's hidden in the utilities bit. KU, let's go K. So that's the first 4, and then what's next? Followed by 1 card to the kitty. So let's have kitty as well. And it's going to be take 1. Okay. That's for kitty. So that's also part of the duck egg troop. 2, 3, 4. But on this second round, you go 4 at a time. And then say 1 to the kitty again. Yep. Range. Yep. And then 1, 2, 3, 4. And the final card being added to the kitty. Okay, so that's my deal. How many spades? Okay, so let's just get what the players all have. So let's go unique of this, and then equals H stack. Actually, if we just text join these. Then we can go equals text join that true if that equals that, then that, and otherwise blank. No, it doesn't like it. All right. Sorry, can I ignore errors somehow? Why is it even giving errors? Oh, right, because let's just go for just K8. Yeah, there we go. That's more like it. And then I need to make sure it's all locked. So that's locked as well. There we go. So that's my deal. It's taking a while to save already. So these are my cards. And then the question is, how many spades does this have? So if I just get, one of each suit, I wonder if they're here already. So I'll just call this a spade. This is club. This one's diamond. This one is heart. So the answer is going to be equals count. It's going to be len of this minus len of substitute this spade by blank 4. That's my answer. sequence of, hopefully it's 20, because this took a while to get to. How long have we spent? We've spent 11 minutes. It's only 10. Okay. Alt A, W, data table, column input cell. What is this? And it's not right. It's not right. So if I go to number 1, it's very like I am getting 1 from this. I do only see 1 spade. Three at a time. What is the answer? So I'm supposed to get 3. I'm supposed to get 3. Did I paste values on anything here? So I believe this. I believe this. I believe this. I believe this. 6 of diamonds being dealt twice. That's why. Okay. 1, 2, 3, 4, 5. Yeah. So I think the king of spades is showing up here twice as well. Okay, that's more like it. Hey, example of 1 still returns 4. Yep. There we go. I've got level 1, 15 minutes in. Great. Decks are reshuffled to dealt again. Okay, so I'm just going to copy this sheet. I don't know what the live scores were for this one. Club is the trump suit. How many big trumps does player 2 have? So clubs is going to be the trump suit. And the player 2 is right here, so we're going to text split that. Oh, bye, Jean. Have a good evening and weekend as well. very tempted to play some music, but I think I'd be copyright struck if I did. Okay, so I think the joker is JJ. I'm going to have to work out what the opposite one of these is. So switch that. Club. It's going to be spade. Spade is going to be club. Heart is going to be diamond. Diamond is going to be heart. And then let's throw if we don't get what we're expecting. So that's the suit. This is the op. Okay, so JJ. So these are going to be the high trumps. And I will just do this in the same row as number 2 here in case we need it for all 4 players in a bit. So hang on, the high trumps are JJ, the the jack of the same suit, so jack and that. Jack of the opposite suit. The ace, the king, and the queen. So ace, king, and queen. Okay, so those are my high trumps. And then what I want to do is basically that equals transpose of that. And then I want to count that 60. Count minus minus of that, 60. No, it's sum, that's why. Okay, nice. So that's my answer. Sequence of 2011 alt AW data table column input cell is going to be this one. Here we go. That's all right. 19 minutes. Okay, bidding. Level 3. So indeed, we do need this for all of the players. Make sure that's locked. Cool. And then I will get rid of the data table here, actually. Data table level 1. Yes, I do. Get rid of that. Small trumps in hand and aces of suit in other hand. So this is the number of big trumps in hand. So how many small trumps is it going to be? Well, let's sort this. So it looks like we have 4s, but only for 2 suits. Ugh. It's a bit disgusting, isn't it, really? So if I go equals cards, so suit is going to actually be equals right of that. The highness is going to be the trump highness is going to be highness. What was it? It was basically jack equals left of this equals is in, so match that to J, K, Q, or A. That's right. X match. Right. And that's going to be is number. Cool. So I want small trump cards to be equals this, where filter right of it equals that. And otherwise it's just going to be 0. So that's the same suit. And then I also want to say it's not equal to these. Not equal to transpose of these. And then this is like a bicol, isn't it? And actually, instead of 0, we could just write JJ in here. JJ. Bicol lambda X or X. No. What? Just get rid of this for a second. So it's or not. And then I want to count if false. Count if false. Right. So not of that then. Some of that. 2. Okay. That's right. And then number of aces. So aces is going to be equal to left of that 1 equals a. Sum n of that minus sum n of the whole thing equaling specifically the trump a, because we've kind of already counted it. Cool, okay. So up and down, and down. There. Lock that. It's already locked. This one isn't though. And this one is locking as well. How much time have we got? We're on 25 minutes. Okay. So each player is willing to bid up to. So actually you can bid in all the suits. What was the question? How much they're willing to bid up to in clubs? No, the last question was the clubs. Okay, so we're going to have to do a data table with multiple suits. So let's do equals a club, diamond, heart, spade. High, small, and aces. And then I guess this is like the order of the suits, maybe? Seniority of the suits. 6 hearts behind and 6 spades. Okay, so we're just gonna grab this whole thing. Is that giving what? Oh, because there we go. So here are my bids. And the highest I'm willing to go up to. Okay, so this is going to be equal to that times, is it 1.75? 1.25. This one's going to be 0.75. This one's going to be 1. Pause. That times that. Sum. And then okay, and then we want to round down. Cool. That's my bits. What suit am I in at the moment? I'm in clubs. So this is actually not right. What bid would the third player be willing to put up to? I have the first player bidding quite high. 3 high cards. Is that right? They've got the Jack of Clubs, they've got the Joker. They've got the Jack of Spades. Okay, yeah, that seems right. So I say the third player is getting dealt this hand, which only has 1 ace. And not that many no clubs, in fact. Am I on the right question? No, that will be why then. Cool, so here are my bids. And then we're doing player 3 only. So this is going to be the kind of answer. This is going to be our data table, Alt A, W. Probably, yeah, we've gone over 30 minutes, so we wouldn't have got this in at this pace. So that's a bit unfortunate, but that's the suit. That's the column input cell. These are the answers. So I'm just going to paste values over that. And I'm just going to go equals that and that. And then unlock the column. So here is what everyone's willing to bid up to. And we're basically looking for whichever one is biggest here. So let's just give them all the kind of appropriate ranks. So equals, why am I on level, did I switch those around? Level 2, 2, level 3. Okay, so equals match of this to here. So here. And then if error, pass. We basically want the max of these. And then if this equals 0, pass, and otherwise give me index of this by this. See if that works. Yes, almost. Number 48. Number 48. Third player has 3 high cards and 1 other ace. Well, hang on. What's the actual answer? No one's watching. So I can say whatever I like. No. 7 diamonds. So we should be in 7 diamonds. Okay. So I'm interested in diamonds. I'm on player 3. So I've got 1, 2, 3. Where's the 4th high card? Oh, yeah, 4. Got 4 trumps. Agree with that. 4 high trumps. We've got no small trumps, and we've got 2 aces. So I agree with that. And the bid is 7. So I agree with this 7. 7 of diamonds. Oh, it's because these aren't in the correct order. Oh. I need to... If I transpose this, would that get the order right? I think that's right. Okay, let's calculate this data table again. Alt H, W, data table, row input cell. I got quite lucky there to get so many right with that big an error. Okay, so let's try this. I guess it's because you're generally only going forward in 1 suit. But yeah, that seems right now. Excellent. New deals. What's the highest number of points they're willing to bid? Okay, that's really easy. Why do they like make a super hard level right at the beginning and then easier levels later? Like, come on. I want to feel like I'm achieving something at the beginning more than I want to feel like I'm achieving at the end. Okay, so we've got that. New data table. Alt A W. Data table, row input cell. It's going to be the suit again. No, Alt H W data table. New row is going to be the suit again. The column cell is going to be this one. And this is going to be 51. So the bids are going to be 0 diamonds. Let me just clear this out. Go sample 4 and VStack it with the sequence. Alt HW data table. Row input cell is going to be this one. No, all right. Row input cell is going to be this one. We're going to have this. So, I mean, we're saying we're not bidding very high here. It all seems quite low, doesn't it? Oh, it's what any player is willing to bid up to. Oh. So this is my player 3 answer. I need all the player answers. What's the 5th question? I mean, I guess I could just copy all of this 4 times. I don't really want to, but it would work. Heck, let's just copy this 4 times. So this one can be linking to player 1. This one. Linking to player 1. This one to player 2. This one to player 3, and this one to player 4. So what was that? So that was a 44, so a 45, a 46. These, oh no, they are different. They're just all the same on the example level. They can't all want to bid to the same things on the example level, surely. Yeah, like, am I on the example right now? I am, right? So, the oh yeah, because these are pasted. So when I copied the data table, it didn't calculate it. It didn't like make a new one. Okay, that and that. New data table here. W data table. Our input cell is going to be that. No. Our input cell is going to be that. Column input cell is going to be that. And finally, Alt A WT, new row input cell is going to be that. Column input cell is going to be that. There we go. That's the solution. This is what all the players are going to be bidding. And the highest bid is going to, well, basically I want to translate this into transpose this to col. Cool. So I just want to translate this into this. And my answer is the max of the respective kind of rows. Good. Okay, so what time are we at now? 42 minutes. That's not very good. This time the players take it in turns to make bids. Okay, but this again feels like it's quite easy. So level 5, example 5. And then instead of taking the max, instead of taking the points, I think what I want to do is just take the, let's just have equals sequence of 30 here, or 31. These are going to be my different levels. And then just H stack of this, with this, except instead of X, let's actually just get the W's so we can see what's going on. So we first bet 100 points. So you always start with this 6, I guess. Oh, that's interesting. Oh, are there any 20 levels here? Definitely 30. Oh, no, 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 no. Oh, no. Oh, that's so annoying. We need to make all of these 10 rows bigger. Okay. Okay, so let's go 10. Go, count it. 10. 10. 10. This is going to go from example 5 up from 71. It's going to be 30. And then we need to remake all the data tables, because of course we do. I'll take WT, for input cell, it's going to be that. J41, column input cell, is going to be A40. It's going to be B3. Suit, column input cell is going to be this. For input cell is going to be this. Column input cell is going to be this. Data table. Our input cell is going to be this. Column input cell is going to be this. Nice. So that's all my data table. Copy that down. There's nothing kind of conceptually hard about this level. So I'm not really a fan of this or the previous one. It's just, it's just more of it in some sense. Cool. So here are my different thingamabobs, different plays. And what I want to do is take the second highest, I think. So if we go for the X match again, I can value this in here. This gives us kind of the order. and then we can go if error 0. No, because that's not about that. It's about the number on the left. I think it's always about the number on the left. So let's just go equals left of this. So it's that we want the second highest number on the left. Then if it's p, let n be that. If n equals p, then 0, otherwise n. And then otherwise a value of n, let's do. Cool. And then we want the second biggest number, large of that 2. What? Oh, hang on, I did the whole array. To a 11th letter of the alphabet, it's going to be K. 84. No, I wanted J, because you have to subtract 1. Okay, so basically, if the second biggest is also a 9, oh no, actually we want the top biggest as well. Ugh. Okay. So what do we want? We want equals if min of these is equal to 0, then we only go up to 6. And I see there are no 0 zeros here, so that's fine. But otherwise, we go up to the second highest bid. So this is going to be the kind of the number that the winner has. So it's either it's going to be 6 or it's going to be the second highest, or if you're above that, it's going to be the highest. So I need to work out exactly what these two highest bids actually are. So the 9. So let's just go. Let's replace them with points. So if or with the matches. So X match this in here. Let's move that over there for now. Equals and then if error 0. And then equals large of that sequence of 2. Sequence of 2. Yep. So these are my actual biggest, and then let's actually look that up. So if this is 0, then NA, otherwise index of this by that. Yes. So these are my two highest bids. And as we say, if the second one is equal to NA, so this is one bidder. So we want 6, and we want the right of this. So those are the bids when there's one bidder. When there's two bidders, we want the first one of these that's bigger than that. So basically we want to do this. Can you go? No. Basically, I want to subtract this from this, and then find how many 4s go into that. So that over 4, round down. And then that's how many 4s I want to subtract off of this. So that minus 4 times that. And then this is going to be my index that brings me back these, I think. So this says clubs is bigger than spades, and it is. Okay. And then if NA of this, then this. Cool. So I claim these are the actual bids that get made. And then all I want to do is look up the points that are associated. So index that, well, X lookup. X lookup these in here, returning from here. Here's my points. 260, that matches the example. That's a good sign. Paste these here. And no, they're not all right. Some of them are right. Okay. They're almost all right. Let's try game number 77. Game number 77. Everybody passes. No, the player 2 always passes, this means. Have I got the wrong rows here somehow? 3, 4, 5, 6, 7. Oh no, it is the 8th one. Never mind. So game number 77. Player 1 and 2 pass. So the 6 of spades and the 7 of hearts. So I think it would be the 6 of hearts, if I remember correctly, that would be bid. Okay, apparently not. What's the answer for number 77? I don't think it's 80, so I think it would be that it would be 6 diamonds. Someone would bid 6 diamonds. So that would mean this 7 of hearts that gets bid wouldn't have been bid. So who bids the 7 of hearts? It's the one at the end. 77. So I see the 6 diamonds and I see the 7 of hearts. So case number 77, and we're looking at player 4 specifically. And we're looking at hearts. And the question is this correct, basically? So high cards. We've got the ace of hearts, jack of hearts, jack of diamonds. That seems right. Other ones, we've got the 4 of hearts, the 6 of hearts, and the 7 of hearts. That seems right. Other aces, we've got one other ace. 7. Okay. So I think this is 7 of hearts based on the deal. 7 heart bid. Hmm. Maybe my deal would have to be wrong then. This ace. 1, 2, 3 small hearts. 1, 2, 3 trumps. Yeah, that's definitely 3, 3, 1. 3 times that. 3 times that is that together makes 6 plus 1. Okay, yeah, I don't know on this 77. Maybe the question is wrong. Maybe something's wrong with my deal or with my understanding of the game. Wait, maybe they only move up one bit at a time. So if you can still do the 6 of diamonds, then you bid that. That would kind of make sense. But also it would mean to fix it, I'd have to bring in like all of these bids and build like a whole ladder thing. I think what I've done here is fast, and would kind of be a much more practical approach to take, even if you don't get everything quite right. But that's probably what's going on. Cool. Common card dealt to player 1, level 1. Okay. How many diamonds have been dealt in total on level 4? Fine. What is the total value of all the bids made in game 73? So that probably I also wouldn't be able to get based on kind of not doing the whole ladder, but only going for the suit of the top, which probably isn't what you're meant to do. But I'm quite happy overall with this. So not going to do that one. I mean, take a look at, let's see if the answer is like a round guessable number. No, it's not. And then level 1, you could basically just do a data table that counts the number of times each card is dealt, because we have the card list here we could use. And then for level 2, yeah, this is again just another data table with a count of the number of diamonds dealt. And actually, you probably just count the number going into the kitty because it's easier, and like subtract off the rest since everything gets dealt. Nice. Okay, I'm going to take a very short break. I'll be back shortly. And when I'm back, we can do the Grand Master and do the final case. It took about an hour to do 500. Okay, hello again. Oh, sorry, 1 minute. Okay, I am back again. I might have to go in a bit based on message. That's okay. It's the 18th of January 2025. January. Why can I suddenly not spell January? January. Just gonna double check that for my sanity. January. Yeah. Don't know why that word suddenly doesn't make any sense to me there. Let's open the case up. It might be a bit late now. Why are you opening up? All right, here we go. The final game, the Super Grandmaster, with chess pieces. And whatever this is. You have a full set of chess pieces to place on the board. Place them on the board according to level 6 rules to maximize the number of points scored. Okay. And we've got this, which very large chessboard with, what's that? 100 rows, 100 columns. And we've got explanations of how all the chess pieces move. Level 5. Okay, so it looks like the pawn might come in on level 5. Okay, well, I know these. I'm lucky enough to know these, so that's good. There's only one cell on the board not occupied by an... Oh, hang on. Let's just start this, really. Okay, there is only one cell on the board not occupied by an opponent's piece where you can place a pawn and attack 2 opponent queens simultaneously. Where is that cell's address? So what I'll do is I'll just go... well, what I'll do is I'll name the different chess pieces, and actually the black ones have a different Unicode character to the white ones, I think. So let's go queen, knight, pawn, bishop, rook. I don't know if there's a king. Don't need it for this level though. Rook. My rook naming hasn't worked. Rook. Why does that not work? If you, I guess if you go, that's an R1C1 reference for the current row. That'll be why. So you can't name the rook R. Just name it rook. Okay. Got everything. I think so. Don't know if there's a king here. Probably not. I'm just going to copy the board, and then I'm going to go equals that equals. Oh, hang on. Needs to get rid of the names from the copied sheet. So equals that equals Q. That equal more like that. Okay, let's go. That one equals Q, and that one equals Q. And then this can be there. And board d1 equals q, and this space is blank. Len is 0. Okay, let's copy that around everywhere. And then let's find true by matching cell contents. Nothing. Looking values. That's a question. Pawn and attack 2 opponent queens simultaneously. Maybe let's drop the len condition. Zoom out a bit and put the conditional formatting on here. Or here. All right, so it's AW14, I think. AW14. Place a knight and attack 4 opponent queens simultaneously. Place a knight. So count if, well, that equals q. Well, that equals q. 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 E4. That equals q. And that equals q. And then let's make sure that we have used the letter q where we can. Let's go like this. Well, let's go like this, and then replace comma with close bracket plus open bracket. Cool. And then we want this whole thing to equal 4. There's potentially one around here somewhere. One, 2, 3, 4. Yep, so that's I78. Nice. Okay, how many chess pieces of each kind are there in the board? Fine. So let's give the board a name. Board equals countif. Board is this. What's the total point value of all of the kinds of pieces on the board? So what are the point values? Up here. So it's basically just the same thing. They're not in the same order, which is a little bit annoying. It's the same thing times XLOOKUP this in here, turning from here. The king is worth 0. Poor king. There's total point value in the following columns. So equals indirect of this and colon and this. Let's go. Let's go if is number, and then it was 100 rows and columns, wasn't it? So if is number that, then indirect of A and that and CY, and otherwise indirect of so basically if it's a letter, then we want indirect of the letter and 1 colon and the letter and 100. Yeah, and then let's just transpose that for consistency. Whoops. Circular references. Yeah, well, I've got to look them up in the board, of course. So, board. Yeah, and then this one has to have a board as well. Board. Cool. Okay, so those are my nice chess pieces. And then I'm going to do XLOOKUP of that in, well, let's give these things names. So pieces, and points. XLOOKUP that in pieces and points. And if it's not found, then 0. It's nice and easy, isn't it? So how many? We're in three levels in already, and I've somehow got a ref error here. Oh, yes, because I haven't basically fill valued that down. Cool. You start placing your pieces, and then they will be threatening. Threatening. Okay. So I think what I want is for every piece here, and these are the white pieces. I mean, just stick it on here. I'm going to basically look at everything they're targeting. So let's go View, New Window, and we can use our complex numbers trick here. So the king, let's bring in the lambdas, equals directions. There's something about here, including diagonals. And these are all the pieces that the king attacks, except he doesn't really go for the 0 in the middle. So just copy and paste that, get rid of the 0. And then this is my king column. And what I can do is I can do complex from indirect, this, these, and then I go XLOOKUP the king across here, looking in here, and then put the hash on the end. Why is that not working? Okay. So what's the most moves a piece can have? It's going to be the queen. Okay, those go any number of spaces. These ones don't. So I think we only need 8 squares here. So let's just make sure the whole thing is 8. So basically what I'm going to do is return from here within L. Cool. So those are my directions for the king. Then I'm going to map those to lambda x in sum x with no. Map those as lambda x in sum x with this. So these are going to be all the board positions, and then I'm going to look up this in the board. Cool. Going to x look up that in here, returning from points. And then if and a 0 and sum. Oh, come on. Okay, so I can't paste values over here for some reason. Probably to do with how I'm splitting up the view window. Yeah, my ribbon is like only responsive on this side for some reason. But oh, I can try pasting those in and I can get it completely wrong. Oh, is that right? Let's have a look at BR31. These are actually, no, they're right. All right. Yeah, let's have a look at BR31 on the board. Have I not locked something here? Oh yes, I didn't lock this. There we go. Okay, and then all I need to do is put the pawn, put its moves down. So it can move, it can do this one, it can do this one. Let's see if that works. Yep. And then the knight. The knight can do all of the combinations of 2 and I. So let's go equals complex 2, 1. Let's go equals that in product, that with I. And let's do equals im subtract 0. No, of course. Let's go 2 minus I, complex 2 minus 1, and then copy that. Okay. There we go. So that's level 4. How many minutes in a way? I don't know how long they had to do this originally, but I think I'm doing pretty well. Level 5. Okay, this is where the pawns move up. And then there's a 6th level as well. Okay, so I think I'm going to, at this point, have a kind of working sheet. So at level 5, example 5, and you can have equals index column G to H, match case B to B. And what are we matching? Specifically, we're matching this. There we go. And I don't know why this is always given, because we don't actually need it. We can just do that. So complex from indirect. Yep. And then is it basically just moving up? Yeah, okay. So up means the well, what we want to do is we want to look at -1. We want to look at -1, -1. I want to look at -1, 1. Yep. So these are my candidate positions that it's going to head to. Lock the column there. And then we want to basically look up those on the board. And then what we want to do is decide which one to go for. So equals, that equals the king, then give it 1,000 points. If otherwise, if it attacks a piece, if it attacks a piece, give it X lookup of what the piece is in pieces, and return points. And if it can't find it, then just give it 0. Okay. So then equals max of this, and then if max of this, if that equals 0, then you want that cell. Otherwise, you want index that match that to that. Okay, I think that's right. And then you link that back over here. Link that down and drag this down for 98 rows. That should not be locked. So you see we move up the rows, and then we kind of don't need this one here. What's the question? What's the total point value captured? So this is going to be equals lookup, like the im lookup of this in the board, and then X lookup that in pieces, look it up in points, It's not found 0. And sum that. Okay, so I get 230. I shouldn't. Because I should get 179. So if that equals 0, let's go up 1, fine. Otherwise, index that, match the point value to there. So we go let's just zoom out a bit so we can see everything. So we go up left, go up left, up left, up left. We go up left again, up left again, and then we go up right, hopefully. Yeah. Okay, so I'm mostly pretty happy with this. Let's have a look at the case. Looks the 2 pawns and CM98. Yeah, to attack the CM pawn, which is the one left, yeah. After that, it continues on column C, yeah. Oh, right, because I'm counting the ones when I didn't capture. So I think if this equals 0 and 0, there was a 0, 0, 0 here, isn't there somewhere? There, yeah. Don't know about this. I'm too high. Let's just mark the path on the board. So we got CK. Where are we? We start from, let's CN 99. Start on CN 99, which is here. Okay. Oops. Okay, that. Knight or bishop, which is worth more here. Worth the same. Okay. So knight, rook, bishop. Max of this is 5. Oh, okay, yeah. So what we want to do is we want to put the comma there. We want to kind of move this out of the way. So it's not part of the max. Yeah, okay. Cool. So what's HVN? Example 5, and then, well, let's just do sequence. We know example 5 is working, so let's do sequence 551. Alt A, W, data table. Row input cell shall be nothing, and the column input cell shall be this. Okay. So, I mean, got some answers for the middle ones, which are all correct. Something's wrong on level 51 and 70. I think they might have had more time to do this one since it's the final. Don't know. Oh. So I'm just going to go if error blank. So I guess you're kind of hugging the wall there. Yeah, it's column A. That makes sense. So got all of those, 27 minutes. And now basically the heavy pieces, we're going to capture everything. So I'll get rid of this data table and then I'll clone this. No, probably be easier to like this is most similar to level 4. I don't know if I had a tab for level 4. Yes, I guess not. Yeah, I guess because I just did it like this. Okay. So I will use a whole new page for this one. And then I'll go, well, at least I'll use the, the selector here. So example 6, CC7, and we do need the piece this time. So queen. And then let's do complex from indirect. Then I'll actually just pull it back from over here. So let's go well, if we just do directions, including diagonals again, I guess we just grab it from the king had the same ones. So Alt H V, so paste transpose. Yeah. So here are the different directions, and then I'm just going to move these about a bit. So I'm going to put all the ones that the rook will do together. That one there, that one there, and that one there. Okay. And then we'll just basically say equals imsum. Well, let's go for that. I'll assume we always start with a blank. Imsum that, and that. Let's do that for 99. That should be enough. Then we'll do a lookup z of this on the board. And then if error 0, and it's going to be what is the total point value. So let's then x lookup that in pieces and points, and 0 if it's not found, and sum all that up. And hopefully this is equal to 374. No. Is it 24? It's 371. 21? Yeah, so I guess we only want to count this one once. So minus sum of these. 374. Okay. So there we go. And then here I'm going to go if that is not equal to sorry, if that equals a bishop, then we want 0, or let's do complex -101, -101. And otherwise that just puts us out the range. That can be those 4. And then this one can be if this equals that. Then this is going to be the same thing, complex -101, -101. Otherwise it's going to be that. Okay. So just link that down here, make my data table. Okay, once again, it's not really liking the whole copy-paste shenanigans going on here. Cool. So now equals sequence of 30, starting at 71. LTWT, column input cell shall be this. There you go. Super Grandmaster. Ooh, and the bishop levels are wrong. Oh dear. Let's take a look at one of the bishop levels, 81. Oh, they're all not bishop levels. What? No, hang on. Sorry. 81. Okay, there we go. Oh, so I didn't copy. Oh no, I needed to lock this cell, fine. And I did lock this one correctly. So here are my actual answers. I'll also fix that error. I've still got one wrong. 177, which is just number 90. So I get 177, and the answers say it is 178. Oh, right, because my subtraction here it doesn't work because it's bishop. So I guess I need to subtract all of them. Or I need to say if it's a bishop plus if this equals bishop equals bishop one zero. Not 1-0. This 0. Basically the piece value, which is usually 0. Okay. You have one full set of chess pieces to place on the board. Place them to maximize the number of points scored. Right. And I don't know how long this took in the original, but let's say I've got till 45 minutes. Right. Have I got the super pieces? I think so. So I could do a data table, or you could basically I could do a data table of all of the cells here, but it would be 100 by 100. So I don't really want to do that. If I have the biggest rows and columns and diagonals, maybe that would be good. I could do a heuristic solution like that. I don't want to recalculate 10,000 times for each piece. Okay, so, well, to be honest, the most important piece to place is the queen. And you can get the queen out relatively easily, I think, if you just XLOOKUP this in points, no, in pieces, returning from points, and then sum, and then if it's not found, return 0. And then you do exactly the same thing, but the side. So already, if you just choose these wisely, you get a good kind of queen and rook result. I'm going to do the same thing with the diagonals, which are a bit trickier. The knights, you do a kind of board 2 solution like this, and you find some maxes like that. Of course, you're not placing them like independently, so it's a bit tricky. But I would do the pawns like this as well. Yeah. Okay, I'm not gonna like actually go through with this because there's not really like a checkable goal to achieve. But I think that's what I would do, is I would take these sums, put the rooks on, and maybe put the queen on as well, depending on how much time I've got. And then I would do this kind of solution for the pawns. But the most important ones to get on are the queens, rooks, and bishops, because they'll capture by far the most things. And we could just put a couple of rooks in. So, maybe we go large 2 of this. Sequence of 2. And then maybe they're both 167, hopefully not. Yeah, but then you could X match those in here, 91 and 47, and then you do the same thing here. So you zoom out, you go large of this, sequence of 2, and then X match of that to here. The row and column, and then you can say, I don't know what 91th letter is, address 191, CM, address 47 AU. So you could go and then 14, 13, and 61. No, one. There you go. So you could go CM 13. Oh, it doesn't even work. Or CM 13. How can this possibly be giving a score of 0? Oh, I just need to fill in everything. Okay. CM13, AU68, and let's just throw in some random. Let's just go like S50, U90, and then G1, G2, AA5, A7, and then let's just go equals P and a sequence of 50, a sequence of 8 plus 50. Let's just go with that. Let's say that, maybe I improve this a little bit, but don't do much better overall in time. Maybe, really you should be looking for the queen and bishops at this point, and kind of looking for max over the foursomes. There you go. Wonder what the actual top answer is. Like if I just move this around a bit. Okay. Nice. Well, I'll call that my Super Grandmaster attempt. That brings us to the end of 2022. Nice. 2023. Okay. How much more do I want to do today? Don't know. Should probably go eat at some point. I'll do Lana Banana quickly and then I'll get some food. So Lana Banana won't take me too long. I wrote this one and it's got a very nice, easy solution. Let's see how long it takes me to solve Lana Banana. And off we go. All right, so Lana is a freaking banana, of course. How many 2x2 grids which contain at least 3 bananas are there? Let's just unhide all this. So equals count if, well, let's name something banana. Count if this is greater than banana is greater than or equal to 3. Down to here. Get rid of this annoying copilot, please. Go away, don't want you. Still a way to go. I'll probably wrap this in N. Shrink the columns, keep it on one screen. Okay, that's what we want. Together that is 37. How many distinct pairs of neighboring bananas are there? So if we're on a banana, then count A, this. I don't want these or these. And what is this complaining about? It's false. 0. Adds up to, if we're on a banana, I think this is right. 2, I don't know, it doesn't sound right from what I remember. No. Oh, no, I'm not counting stuff twice. Adjacent cells horizontally, vertically, or diagonally. So 1, this is involved in 1, this is involved in 3. Two. Oh, right. So I didn't include this bottom row because of the way I did this, or this kind of right column. So I'm getting 204, which is correct. Okay, this one's a bit hard. We need to do level 5 for this one. So if Lana starts in these cells, moves down, how many bananas will she collect? So what's the easiest way to do this? I think what we want to do is just equals offset this and 20 or 40. Or is it, yeah, 40, 1 on the map, of course. Okay, I don't know how offset works. But basically, I want to do a join of this cell with the offset version of this cell. Let's just go with address of that row, column of the same thing. H80, that's not right. Column of indirect of that D80. Okay, this is more like it. What I'm going to do is I'm just going to go equals index map of this. To same thing, but of H42. What's the index there for, Harry? Don't need it. I'm just so used to the late binding used with index, I guess. Banana. Equals that. Sum n. Nice. Drag that down. Excellent. Lana starts in. Oh yeah. So if she kind of moves diagonally down like this, and then if she hits a wall, she starts moving down. So maybe she hits the wall here. She starts moving down instead. So I will set up a thing for this one. It's a bit tricky. Cool. So example 2, and then I'm going to index these things here. So G to H, G to H, and I'm going to match this thing here to case B to B, 0, 0. So that's my starting point and my arrow. So I'm going to bring in my lambdas. Alt SL doesn't work because the ribbon is over here for some reason. Come on. Come on. Oh no, what's happened? This shouldn't be taking a while. Okay, fine. Cool. So complex from indirect of this. And then there's only 2 options here. This one is complex minus 1, sorry, 1 minus 1. This one is 1 plus I. So X lookup, that's in here. That's in here, returning from here. This is my direction. And then basically what I'm going to do is go equals im sum that and that. And then I want to do equals if imaginary of this is less than 2 or it's bigger than 40. Then it's less than 2 or bigger than 40, then we basically want im sum of 1 with this instead. And otherwise, this is fine. And then that can link to that. Yep. Bring that down, 40 rows. 40 rows. And then we want to go equals, we'll just name this hill, I guess. I think it's meant to be a hill. So equals im lookup of these on the hill. And then if NA is 0, and then sum n banana equals that 2, which is correct. Then we want sequence 20, 11, alt AW, data table, column input cell is that. Taking a while, but ooh, ouch. Let's have a look at number 13. Luckily, the first 3 are the ones you enter, so we would have caught this. We'll just split this out. Why? Okay, we've got AG19, AG19, and then we're going down like this. Has that changed? No. Cause address from complex. So these are the cells that we're going in, I think. AG19, AF20, AE21. AD22. I mean, this all seems right. L40, L40. Yeah, but we only pick up 3 bananas. So which of these is not like the others? 1, 2, 3, 4. So S33. Agree that is a banana. X28. That is not a banana. Why are we getting a 1 there? 28 plus 24 would be x. What? Oh, hang on. It's because the hill needs to be A1. Okay. So everything was kind of offset down and right by 1 because I didn't assign hill to the right name, which is why these kind of column letters and things generally, it's nicer when they're here or here. I can't remember whether they added them on this one or not. Okay, but we've only been going for 13 minutes, so we're still in with a shot, getting full marks here. So, Lana can go in any of the directions, down left, down, and down right. She starts on these cells. How many can she collect? Well, what we do is we copy this map sheet, we get rid of all this, call it level 4, and then we write the following formula, and we can get rid of our sheet 1 data table as well. We write the following formula, and we get rid of the name, the new name of banana as well, before we forget. We write this equals if this equals banana. So if I am on a banana, and then 1, 0, plus, so you just replace this with n. Am I on a banana? Plus the rows below. Oh no, no, no. Okay, I did it on the wrong worksheet. N of this equals banana. Banana workbook. No. Banana. Get rid of that. Okay. Copy that. Paste formulas everywhere. And then add on the 3 below. And it's specifically, we want the maximum of this. Nice. Cool. So if we just go equals indirect of level 4, and what the exclamation mark, and this, that gives us the corresponding position here, which gives us the number of bananas. So, here, for example, there is a banana there, and then whatever path I was on that was optimal before is still going to be optimal for the other steps. So I get 3. And what's beautiful about this, the reason I named it level 4 is because level 4 is the same thing, just higher up. So it's still looking good. And then level 5 is the same thing, except you can't eat 2 in a row. Ugh. Level 5. And Dim came up with a very good solution for this. I'll just insert a couple of rows here. And the solution that he came up with was the max of, if you're on a banana. So if you're on a banana, then it's the 1 plus the max of everything you can reach in 2 goes, and you can go in the kind of 3 down directions, and you can go to the right as well. So where can you get in 2 goes? You can go there. You can take kind of one of those 3 down steps and then go to the right. Or you do all of these. Yes, because it's kind of down with any of the other 3 for the middle, and then it's down, left, and down, right, down, right. But I must not forget to make sure all 3 are included. And then otherwise, it's just the max of the three below. So oh no, hang on. That's only for the bonus. It's only for the bonus. So this is going to be what's the question on the bonus? This question Lana can move right as well as these ones. She also has a stomach ache. What is the most bananas she can collect? I don't think I've got it right. What are the answers? 39. Yeah, I've not got it right. I think the actual answer is like 40 or 41, but the case was wrong in this on this one. Why? Okay, let's just do level 5 first. So if you're on a banana, then it's the max that you can get to in 2, which will only be these ones. Otherwise, oh, because I didn't include going 1 to the right, that's why. Okay. So I'm going to just copy this formula down. Level 5. But of course, remember I kind of pushed everything down to the left, so I'm just going to copy this first. And then I'm going to just get rid of this, get rid of this. And they're all correct. Nice. And then level 5 is the same thing, but you can also go one step to the right. So for the blue ones, you can also get to here. The blue ones you can get to here and here. And for the green ones, you can also go here. That's more like it. So then the answer is 40, but the case says 39. Basically, what happened there was that the column, I basically had instead of like pushing this along one column, I had a different formula on the end, and that formula on the end wasn't adjusted properly for these changes, and so yeah, I don't know exactly what went wrong, but basically you took this path down and you ended up with 39 instead. There we go, that's Lana Banana. And I should get some food. So that'll be all for today. If you enjoyed it, whoa, look at that. I don't really know why I'm streaming these. I think it's just good to, if I'm doing the practice anyway, it's good to kind of put it out there as something people can watch if they want to. I think if I compare my video solves to the people who attempt them live, I've still got a way to go to catch up to them. But at least I'm getting kind of probably good time per case, more or less at the moment, because some of these ones from 2022 are quite hard. If I stream again, I guess I'll be doing these ones. Pass the Arrows, I really like. Cricket Darts, it's all right. Backgammon, didn't really like Backgammon. It was very, very difficult. And it was difficult because there were lots of instructions. So it wasn't kind of a very level playing field for everybody, especially people who didn't speak English. But also within 30 minutes, that you couldn't parse those instructions, even if you could speak English very easily. V-Lucky knocked me out this year. Bit of a beef because the answers on that one were wrong on the levels that I was trying to solve to get my points back up. So I don't know whether the answers will be right on this file, but if they aren't, I'll be calling it out. I wrote this one as well. This case is quite neat. It's not anything special in my opinion, though. Yeah, so there we go. That'll be it for today. Go and get some food. I hope if anybody does watch this that you enjoy it. I'm not kind of obviously that engaging or trying to be that engaging, but it's something people can watch if they want to. Right, goodbye.